Welcome everyone. In this video, we will talk about the expected value, variance, and standard deviation of discrete random variable. An expected value is basically the mean of the variable. So the other name of expected value is mean, and we will denote it as mu. So mu is equals to expectation of x. So these two notations are basically for mean of the discrete random variable, and the formula says it is equal to summation of x times probability of x, which means that in the random variable table, so you have this x, their possible outcomes, probability of x's. You have to multiply each of the x's with the probabilities and then add them all. Why you have to add them? Because you have a summation sign. So that is basically the formula for mean expectation of x, which is equal to summation of x times probability of x, meaning you are multiplying all the x's with the probabilities and adding them all. So here we have done a simple example, a simple exercise where we have multiplied x's with the probabilities. 0 times 0.25 plus 1 times 0.50 plus 2 times 0.25. So if you add all of them, you will get 1. Why you are adding them? Because you have a summation sign. So this is the formula for mu, or mean of the discrete random variable. Now, why you're calling it weighted average? Because we are multiplying probabilities with it, which is why this is weighted average. If we hadn't done it, it could have been just average. In normal arithmetic, we get the normal averages by adding all the values and dividing it by the total number. So that is normal average, and weighted averages with the probability. I will show this same example with my whiteboard, how you are going to do it in your copy so that it takes less time to solve any sort of math like this. So you have x's, which is 0, 1, 2. Then you have the column probability of x. Here you have 0.25, 0.5, then 0.25 again. I'm just using the last example that we have seen, number of heads. So these were my probabilities. Now, to get the mean of this variable, I will create another column where I will have x times probability of x. So this is another column, x times probability of x. Now I will fill this column. 0 times probability of x, so 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 0.25 is 0.5 again. So if you add this column, 0.5 plus 0.5 becomes 1. So when you add this column, you will get your mu, because your formula for mu was summation of x times probability of x. So that was the formula. So when you create this column, you basically have to add them all to finally get your mu. So your mu is equal to 1 in this example. All right, now I will talk about the next topic, which is variance and standard deviation of discrete random variable. The formula for variance is written here. The notation is sigma square. So this notation is called sigma and you have a square. So sigma square is the notation for variance and the formula is summation x minus mu whole square times probability of x. That means you have to subtract mu from each of the x's, square it, and then multiply it with the probabilities. Yes, it sounds a bit complicated, but when you do it in the table, it is quite easy and less time consuming. So I will show it again on the whiteboard how we will do it. So here I will erase this first. Here I will create another column with x minus mu whole square times probability of x. So this is another column that I've created and I will fill this. X minus mu whole square. So you have to subtract mu from x's and then square it. 0 minus 1. 1 is your mu. So 0 minus 1 is 1. Then square it, which is also 1. 0 minus 1 is basically minus 1. And then you square it, it becomes 1. And then you multiply it with the probabilities. 1 times 0.25, which becomes 0.25. Right? Yes. For the next one, 1 minus 1 becomes 0. Then square it, which will be 0. 0 times 0.5 is 0. So this is 0. Third one, 2 minus 1 is 1. 1 square is 1 again. 1 times 0.25 will be 0.25. So this is 0.25. Always remember to sum it, add the column. So we will add this column and this will be 0.5. All right. Why we are adding this column? If you go back to our slide and see that we have a summation sign in the beginning of the formula. That means we have to add the column. So if you add all the values, you will get the variance. So which is why we added the column to get the variance. So our variance or sigma square is equals to 0.5. Now, if you remember from stat 1.1, if you don't remember, that is also fine. If you square root your variance, you will get standard deviation. So you have to square root your variance to get your standard deviation. Let's go back to our slide again. So it says standard deviation is simply the square root of your variance. So you are square rooting your variance and you will get your standard deviation, which means that if you square root 0.5, you will get 0.707, which will be your standard deviation. So let's go back to the whiteboard again. The standard deviation will be only sigma because you're square rooting it, and if you calculate it in your calculator, it will be 7.707. Let's go back to the slide again. So yes, we have variances, standard deviation. We also covered expected value, and we have also seen that if we do it in the table, it takes less time and easier for us to calculate, because you may get a lot of values or outcomes for x's. Let's say you have 10 values. So it will be a lot of calculation, and if you have a table, it will not be difficult for you to sum it up or get the final result.